Hello everyone, my name is Ishaan Bhaduri. I'll be presenting my research on the combined effects of sleep and diet quality on hypertension in US adults. This project uses population data from NHANES 2015 to 2018. It focuses on understanding whether a composite behavioral score can predict hypertension better than sleep or diet alone. Hypertension, or high blood pressure, is often called the silent killer. Globally, about one-third of adults have hypertension, with almost half of them unaware that they have this disease. Most people don't feel symptoms until it's too late. It's a major risk factor for stroke, heart failure, kidney disease, and dementia. In 2023 alone, almost 10 million deaths were attributed to hypertension globally, including about 664,000 in the US. Because it's so widespread and preventable, understanding its behavioral risk factors is incredibly important. We need simpler screening methods, which is one of the reasons behind this project. Hypertension is measured through blood pressure monitors and divided into categories based on the degree of severity as shown in the table here: normal, elevated, stage 2, and severe. This categorization was published by the American Heart Association and was used in this study. Many prior research studies have focused on individual behavioral factors and their relation to hypertension. For example, studies show strong links between poor sleep and hypertension, poor diet and hypertension, as well as the roles of smoking and alcohol. But this literature is mostly single factor specific. That is, each behavior has been studied separately. But no research has been done regarding how these behaviors interact, especially sleep and diet, which influence each other biologically and behaviorally. When I reviewed the literature, I noticed a major gap. While sleep and diet have each been studied extensively, almost no studies have looked at their combined effect on hypertension. Further, there were zero population-level studies that tested a sleep and diet combination across a large population size. I realized that if we need to improve screening measures, we need to improve ways to predict hypertension across a range of behavioral factors. I initially started with 5 behavioral factors to develop my hypothesis: sleep and diet quality, alcohol consumption, smoking, and obesity. Through literature survey, I understood that the relationship between light and to moderate alcohol consumption and hypertension was inconclusive. Smoking presented more as a factor post-hypertension than before, and obesity as a standalone factor strongly affected hypertension but overlapped with sleep and diet, so it was difficult to isolate a combined effect. Hence, it would be best to find non-overlapping factors. Based on this, I decided to frame the research hypothesis around sleep and diet. My hypothesis was that sleep and diet quality would each be associated with hypertension, and that a composite measure combining both, called the Behavioral Risk Score or BRS, would better predict hypertension than either factor individually. This study uses NHANES, a national US survey that combines interviews, lab tests, and physical exams. I used the 2015 to 2016 and 2017 to 2018 datasets and merged sub-datasets called DEMO, BPX, BPQ, DIQ, MCQ, SLQ, and dietary intake file DR1TOT using a unique identifier. I started with 19,225 records. After exclusions for age, cardiovascular disease, diabetes, and missing data, the final analytical sample was 6,335 participants. To ensure that research quality was maintained at the population level, I used NHANES survey weights, strata, and PSUs to maintain national representativeness. A key step in the research was to create a composite score, which I termed as BRS, or Behavioral Risk Score. To create that, I first created 2 category scores called SQS, or Sleep Quality Score, and DQS, or Diet Quality Score. For SQS, I used 3 data points from the NHANES SLQ dataset, which captures sleep disorders through a survey questionnaire. These are sleep duration, snoring or stopping breathing, and self-reported trouble sleeping. I created subscores for each of these factors and then added them up to give a composite sleep score, or a score of 1 meant poor sleep, 2 meant intermediate sleep, and 3 meant healthy sleep. For DQS, I studied literature and arrived at the conclusion that sodium and potassium intake was a good data-driven approach to understanding diet quality because they have strong but opposite effects on hypertension. Using data from enhanced diet surveys, I created a sodium-potassium ratio after converting those values from milligrams to moles. Diet quality was determined as healthy if the ratio was less than 1, intermediate if the score was between 1 and 2, and unhealthy if the score was over 2. SQS and DQS values were added for each record to create BRS. BRS is categorized as poor with a score between 2 and 3, intermediate with a score of 4, and good with a score above 5. For statistical analysis, I ran logistic regression using Stata 19.5. I built 5 models: BRS only, sleep only, diet only, BRS and sleep, and BRS and diet. I adjusted the models for age, gender, race, education, marital status, and poverty to income ratio. I then performed logistic regression on each model and calculated odds ratio, p-value, 95% confidence interval, t-value, and standard error. To find the best model, I used a cocky information criterion, or AIC, where here lower AIC means better model fit. These are the unweighted descriptive percentages for each category before running regressions, and these show some interesting findings. For example, prevalence of hypertension is high amongst the African American population. There is a clear trend that prevalence of hypertension increases with age, though it seems to affect females more than males. College-educated population has lower occurrence of hypertension than people without high school education. And on the lower right, people with poor sleep and diet combined have a higher prevalence of hypertension than people with poor sleep or poor diet alone. Descriptive trends in the data added to my confidence as I ran survey-weighted logistic regression analysis. Moving on to results. In the individual models, Model 1 for BRS, Model 2 for sleep, and Model 3 for diet, we see that all 3 variables show significant associations with hypertension. Poor sleep and poor diet nearly double the odds of hypertension. BRS also shows a strong association. One important detail in the forest plot is that the 95% confidence interval for BRS is noticeably tighter than for SQS or DQS. This means the model's estimate for BRS is more precise and less variable. This table summarizes the 5 models. The key finding is that the composite BRS shows a strong association with hypertension with 80% odds. SQS and DQS standalone models also show a strong association with 2 times odds. Interestingly, in the combined models, BRS shows a stronger association with hypertension than SQS or DQS in their respective models. The colors signify when the factor is considered significant versus when not. I used a cocky information criterion, or AIC for short, to test model fitment. It estimates the quality of each model relative to each of the other models, thereby providing a means for model selection. Using AIC, we see that adding BRS improves the model significantly. Model 4, which combines BRS and sleep, outperforms the sleep-only model by more than 26 AIC points, which is a large improvement. Similarly, Model 5, BRS and diet, also improves the diet-only model by more than 15 AIC points. This supports our hypothesis that the composite measure provides better predictive value than individual factors alone. I found that poor sleep and poor diet each significantly increased the odds of hypertension. But when combined into the behavioral risk score, the model predicts hypertension better than either factor alone. This shows that multiple behavioral factors together provide more explanatory power than looking at behaviors in isolation. Clinically, combining sleep and diet measures may help improve early detection and risk stratification. Future work could include longitudinal studies to see how changes in sleep and diet impact hypertension over time. We can also expand BRS to include other behaviors and build a digital screening tool that estimates hypertension risk from simple behavioral inputs. Thank you. These are the main references used in this study.